Today we're going to go over a simple architectural pattern that will be great for you to have in your toolbox when developing distributed systems, and it's called the fan out pattern. Now, to achieve this, we can use AWS's pub sub offering SNS, and the overall benefit of SNS is it allows us to decouple our message senders from our message receivers. Therefore, a single message can be sent to an SNS topic where it can be replicated and pushed to multiple endpoints. For example, let's say we had an order service, and when a customer has placed an order, we also want to send that to a shipping service. Using SNS, the order service can send the order in a message to the SNS topic, and the shipping service can subscribe to that topic to receive the message. But what if we also needed the order service to send the order to the service that emails the customer's receipt? Well, we can simply get the email service to subscribe to the SNS topic. SNS's decoupling of message senders and receivers makes this simple. But let's for a second pretend we weren't using SNS and the order service itself was sending both of these messages. The service would have to send 2 messages for every order that's created. This is inevitably going to take its toll. But what if we wanted to send the order to another service, say a test environment? Not only are we going to have to make code changes to the order service to send this message, but we're also going to add another request to the service's workload every time an order is created, which would then bring us to 3 calls, which would make this even more computationally expensive every time we add a request. Now, with SNS, if we wanted to send the order to the test environment, all we'd have to do is get the service ingesting the orders to the test environment to subscribe to the topic, and done. Now look at how our diagram has progressed as we've added each subscription to our topic. With each subscription added to our diagram, you can start to see that it resembles a handheld fan, which is where the pattern gets its name. But we don't have to stop there. There are still improvements that we can make to this pattern, because another problem that we may run into is the downstream services may not be able to handle the number of messages coming from the topic, because currently there is nothing stopping the order service having a sudden spike in traffic. Maybe it's Black Friday or something like that, and it will send a whole load of messages to the topic, which will then send those messages onto its subscriptions. For example, the email service is only going to have a finite amount of resources to handle a certain number of messages. Once that limit has been exceeded, the service is going to fall over. To avoid this, we can add a layer of protection between the topic and the service by adding a queue in between them. This can be achieved by adding SQS, Simple Queue Service, as the subscriber to the topic, which the downstream services can then poll to receive their messages in their own time. This way we can guarantee that if any unexpectedly high loads occur, then the downstream services will be able to deal with it, because this is what queues are designed to do. So hopefully next time you are designing a distributed system, you have a new tool in your toolbox in the fan out pattern. If you enjoyed this video, please make sure to like and subscribe. Thanks for watching. Cheers.